So welcome to lecture 12 part 2 Introduction to Logic Families. Here we will discuss about CMOS NOR gate. What does it mean? Our CMOS will be working as a NOR gate. So you already know the construction of CMOS. Like if we connect PMOS and NMOS back to back, then it will work as CMOS. But for CMOS NOR gate, you need to add two PMOS back to back and two NMOS in parallel. So two CMOS in series and two NMOS is in parallel, and if you connect such a way, then it will be CMOS NOR gate. So here A and V is the input for two PMOS Q1 and Q2 transistor, and A and V is the input for NMOS Q3 and Q4 transistor. VDD, this one and this one is output, and this is ground. So the concept is, if we connect the PMOS with pull-up register or with VDD and NMOS with pull-down register or 0, then we can get the CMOS NOR gate. So from the previous slide, we know our PMOS will be on for 0 volt and off for 1 volt. Similarly, our NMOS will be on for 1 volt, off for 0 volt. So if you want to determine the truth table for CMOS NOR gate, so we have to input A and V, so you can write A and V. Q1 and Q2 is the transistor for PMOS, Q3 and Q4 for NMOS, and V0 is our output. So when A and V is 0, that means A is 0, V is 0. So 0 means this transistor is on, and again V0 means this Q2 is on. So this on means VDD here to Q1, this is shorted. On means shorted, and Q2 here, this is shorted as well. So VDD is connected to V0. That means we are getting output high. And for this NMOS 0 0, so 0 means this is off, this is off. Off means this is open circuit, this is open circuit. So we are V0 is not connecting to ground here. So only thing we are getting here is for 0 0, we are getting V0 as 1. Just consider for the next case 0 1. So 0 1, so 0 means this is on, this is shorted, but 1 means this is off, that means this is open. So we are not getting connection VDD to V0 again. So 0 1 means 0 means this is off, and 1 means this is on, V1 on. So on means this is shorted here and this is open, but still as this is shorted, so we are getting V0 is connected to ground, so we are getting output as ground. And for this one, so this one will be on, this one will be off, so you are not getting the connection. Again for 1 0, so 1 means this is off and 0 means this is on. On means this is shorted, but here this is open, so you are not getting the connection VDD to V0, right? And for 1 0, so 1 means this is on, this is shorted, 0 means this is open, so we are getting the connection V0 to ground this way, right? So again we are getting the output 0 here. For the last situation 1 1, so 1 1 means, so this one off, this one off, right? So off means this is open, so we are not getting the connection VDD to V0. And for 1 1, so this one means this is on, this is on, this is shorted, this is shorted, so V0 is connected to ground, then our output will be 0. So if you look at the truth table carefully, you can see when our both of the input is 0, we are getting the output as 1. For other combination, we are getting the output as 0. Like if one of the input is 1, then we are getting 0. If both of them is 0, then we are getting 1. This is the basically truth table for NOR gate. So we can see our CMOS NOR gate circuit work as a NOR gate. So here is the assignment for you, what we already discussed. Previous slide we discussed CMOS NOR gate, but you need to do the assignment for CMOS NAND gate, which is the just almost the same concept. But right now your CMOS will be working as a NAND gate. So you need to draw the truth table and circuit diagram. Thank you. So here's a couple of assignment for you. So I suggest you try to design PMOS NAND gate, PMOS NOR gate. Just consider the concept PMOS will be on and logic 0 off when logic 1. Similarly, you design NMOS NAND gate, NMOS NOR gate, and the logic is it will be on for 1, off for 0. Also design of universal gate using NMOS, where you need to consider vertical NMOS as NAND, horizontal NMOS as NOR. So in next couple of slides we will discuss about bipolar logic family, like register transistor logic RTL, direct coupled transistor logic TCTL, integration integral logic I2L, diode transistor logic DTL, high threshold logic ASTL, transistor logic TTL, Shockley TTL, emitter coupled TTL. So register transistor logic or RTL. So which means we'll use register and transistor to implement a couple of basic gate. Like if we can implement one of the basic gate NOR gate using RTL, we can implement any other basic gate. So this is one of the example of register transistor logic. So we have input which is connected to R4, the input resistance, and it is connected to the base, and also at the output side we have RC which is connected from collected to RC to VCC, and here we have another input B which is connected to base through RV resistance, and this this collector is connected to RC to VCC. So we will now investigate how the RTL can be worked as NOR gate. So if you can implement NOR, or you can implement any other gate, because this is one of the universal gate. So we know when our base V is high, transistor T goes to saturation, which means short circuit. So when our base is high, if we apply high voltage here, then our transistor goes to saturation, or it is short circuited. When our base is low, that means 0 here. If we give 0, our transistor T goes to cutoff, which means open circuited. This is open circuited, right? Okay, so let's consider a couple of cases. So our input is A and B and output is V naught. So the output here is V naught. Where input is 0 here, A input is 0. So 0 means this is low, right? So if phase is low, then T will be cut off. So that means this is open. Here again B0 means this is base is low, so transistor T is cut off mode. That means this is open. So this one open, this one open. So we are getting V naught. So this is connected to actually VCC. So we are getting V naught as high. So for 0 0 our output is high 1. So this is the illustration. So this is open, this is open. So that means VCC is connected to VDD. And for the second case, like if we consider 0 1, so this is 0, this is 1. So this 0 means again the input is 0, that means transistor goes to cut off. This is open circuit. So here it is shown this is open circuit, and for this 1, that means V is 1 means this is high, transistor goes to saturation, this is a short circuit. So our V0 is shorted to the ground path, right? So we will get the output as 0. This is open circuit. As we got the connection here, so V0 will be connected to ground. So we are getting for 0 1, getting 0. Now consider the third case. Third case is 1 0. So if this is 1, this is 0, that means so this one is shorted, this one is open. So we are getting again the connection V0 to here to ground, right? So again 0. And for 1 1, so if you consider the fourth case 1, that means this is shorted, this is shorted. So if both of them are shorted, obviously V0 is going to be 0. So 0. So if you look at the truth table carefully, we can see if both of the input is 0, output is high, otherwise output is 0, which is the expected output of NOR gate. So we can tell that through the RTL transistor logic, we can implement one of the universal gate, which is NOR gate. So we can implement any other gate. Thank you. So previously we implemented two input NOR gate using RTL logic. So this is the diagram, a schematic. Like if you are asked to design three input NOR gate, so we need to include another input. So this is A, this is V, and this is C. So in between V0 and ground, we need to plug in another input, means another transistor through that RC input resistance. So this will be our T1, this will be our T2, this will be our T3. So if we are asked for an input NOR gate, so we need to plug in an input similar to this way. So this slide is about your self-study. So direct coupled transistor logic. So we are implementing basic NOR gate for direct coupled transistor logic. So the answer is given here for 2 input NOR gate, how you can get the truth table. Also for the 3 input NOR gate, how you can implement it. Just you need to plug in another NOR gate, that's it. So I suggest you try to solve it by yourself.